Aha, meeting recording is in process. Process. Wow, I totally screwed that up. All right,
All right.
we're good to go. So, good afternoon, everybody. How are you doing today? Third Thursday. For those of you who don't know me, my name is Keith Rivera. I got my boy Jeff Kriz on the line as well. He has been on these, so if you don't know him, now you know him. But today we are going to be showing you a little bit of how the sausage is made. So we're going to show you StarSim, right? And this is actually our geosteering simulator that's embedded within StarSteer. That is actually the machine that makes the Geosteering World Cup go, right? So this is a great tool that you can have in your wheelhouse to help train somebody new, right? Jeff, what else were we talking about earlier? I think you even
Yeah.
said,
I mean, the
yeah,
title says it, the ultimate training tool. So we're going to show you how to set it up for yourself step by step. It's also
mhm.
great for, some of a skills test. Maybe if you're a service
Hiring.
company, you're hiring, right? Somebody says they can use StarSteer. Okay, come in here and show me what you can do, right? Um,
Yeah.
the other thing is if you're cool enough, and you got to be really cool, you might want to get together with your buds and have a little game night
You
running
know,
them.
geosteering off. You know what I mean? I told Jeff that would be a lot of fun, but knowing myself, I might turn it into a drinking game. All right, Jeff, take it over, man. Let's walk through StarSim.
Yeah, so if you guys missed the Geosteering World Cup, this year we had 210 participants. Um, and essentially what we're doing, we created a model, we created an answer key for a well that existed. We cut it back and then we ran StarSim. So we pushed data for each participant. So 210 participants are being pushed simultaneously. And this is kind of what it looks like. Data is pushed every 2 minutes, and that's the result. So next year, if you didn't get in this year, check it out next year for sure.
Jeff, just for my curiosity, of those two
Mm.
little sticks, what was the red one? What was the blue one? Was the blue one
The red, yeah, the
the
red one was
robot?
the North American winner on the unconventional well. I think the green was Latin America, yellow was Middle East, and I think the purple one here is our robot.
I was gonna say,
So
I
that
think it was a
that
robot because I think I remember it skirting the top towards the end, and it was like, man, I would have gone down, but
Yeah,
okay,
so we ran StarSeer's auto steer function while this data was pushing, and this is the result we got in this blue well here. So actually did pretty well. I think overall the robot placed something like 27th overall for the entire
hmm
competition. So
yeah,
not too bad for 210 participants.
still no match for our, it's organic brethren,
No, no, no.
Yeah.
All right, let's get into it. So we're just going to show you how to go through the setup, what you need, what the prerequisites are for your sim setup. So a few prerequisites are required. So number one, the most important thing, we need to make sure the Python libraries are installed. You can find those at kb.solo.cloud. The link is also included in the description of each of the simulator scripts, or maybe just the StarSim script, but it is there. You should be fine if you've installed these before, but if you've never gone through it, definitely make sure to do that.
And honestly, while you're doing while that's up here, guys, I would bookmark um, that web location, right? kb.solo.cloud. It's a slew of information in that thing, and Jeff's going to show you a little bit of what that KB looks like. And if you, for some reason, if you don't think you have access, just reach out to one of your account executives. We can get you access. But if you do have access, awesome, bookmark it and refer to it. It's a great resource.
Definitely. Next thing you'll need, really just any completed well, right? You could put it in its own project. So basically a steered well with an interpretation that you think is as correct as can be. Next, this is something I learned recently, no underscores in your well name. You run into some problems when you start trying to define the path to your model folder later in the process. So just to save yourself a headache, try to make your well name fairly simple.
So no underscore, can you do spaces?
You can do spaces, you can do dashes. You definitely can't do underscores. Slashes might be questionable, so maybe avoid slashes too.
So avoid dashes, slashes, underscores, anything like that.
Dashes
Okay.
are fine. I know dashes are fine.
Dashes are good. Okay. All right. You can use dashes, no underscores or backslash or anything like that.
Yeah. Next, current StarSim scripts. Really, they should be available in whatever version you have installed. So for some reason it's not working, you can go to the KB, find the scripts there, and try to use those ones. But it should be fine in your local version. Last but not least, we need type logs to model. So we need logs that exist in your type wells. We can't create a model from a log that doesn't exist. So whatever options you have available in your type well, that is what you can use to create your models here.
And folks, just as a reminder, if you have any questions at all throughout this webinar, please, you can either throw it in the chat or in the Q&A, and I'll be monitoring that and I'll field them and then bring them up when I see them. So
perfect. Next. So script, the entire process involves 4 different scripts. We'll go through them step by step here, but it's actually a fairly quick process once you get clicking through. So hopefully we can show you this in a matter of minutes. Step 1, 2, 3, and 4. We'll go through the model generator script. Then we'll do an answer model. We'll set up our well cutting script, and then we'll actually start pushing data with the StarSim script.
So while that's up, Jeff, we were going over this, guys, and I was like, oh, Moz. So remember Moz, because in the order of sequence, right, in the steps, it is important to do. And the reason why I say that is because in the Python script editor within StarSteer, it's those scripts are organized alphabetically. So it shows up as answer model, then model generator, StarSimming, and then well cutting, and then well cutting, right? But you actually want to run the process this way. So just remember MAWS, M-A-W-S, and then that'll be model generator, answer model, well cutting, and StarSim. Me. So
Absolutely.
just helpful tip.
Good point. Good point. All right, I'm going to pull up my model project. This is basically my finished well. This is the well I'd like to simulate, right? Let me just grab my browser here. Let me move it over here. Have a look. All right, and of course, if you want to skip this video, if you're watching it later, we do have a resource here on the KB. You can find it under the StarSteer manual. Under Geosteering Simulator, I basically have it all written here step by step. It goes through each script. You can follow along. I have an example here. It's actually the same example I'm about to show you. So yeah, feel free to use both resources and develop one with your own data. All right, jump back to start here. Okay. First thing. All right, so we have a completed well. It's been drilled. It's been interpreted. I'm happy with this interpretation. All right. I am in geosteering mode. I can see how well it's correlating. Not too bad of a correlation here.
I think it looks like a pretty good correlation, to be honest.
Yeah, it's pretty good. And we have several logs that we can create models from. So I'm linked to one type well down here. We actually have a density curve. We have a true resistivity, gamma ray, of course. And in this case, we actually have ROP. Now, the current version of the script actually requires ROP, and I'll show you how to get around that. Typically, you probably won't have an ROP curve in your type well. So because the World Cup calculates the final score based on in-zone percentage and ROP, that's why the script requires it. So we're actually maybe going to develop a version that won't require ROP, but it's actually a pretty easy workaround. So I'll show you how to get through that step.
Perfect.
All right. So for those of you who've never used Python before, we're just going to come up here to the Python tab, open the Python calculator window. Then we can find a list of these geosteering simulator scripts under the templates folder. All right, if I check these out, you'll notice that I can't edit any of these. So what I have to do You just need to create a copy and then paste them down below, right? So we'll start with the model generator. So I made a copy, I've renamed it to webinar model generator.
Moz.
All right, and now I can start, yeah, mod. Now I can start to edit these inputs, right? I can reveal more windows here. When this is toggled on, this is just a description of the script itself. So go ahead and read that. There's the Python libraries link if you need to download those libraries. And to create more space, I'll just go ahead and hide, right? We have the input section here in the middle, and then the actual Python code. I can scroll through. If I don't need to, I don't really need to be in there, I'll just hide it, make some more space for myself. All right. So to set up the generator script, model generator script, we want to define a path to save these model files. So if I double click in this value box, I can go ahead and define a path. Right, I have a folder here already. I've created a folder called models. I'm just going to click in there. I'm going to select folder, and I've defined my path. Right, I have one well in this project. That's probably what I'd recommend. Keep it to one well. It simplifies things. So I can leave it an active lateral name. I can also go ahead and just drag and drop the well into that value. I have an active interpretation.
Yeah, I'm glad you did that, Jeff, because I was going to say, this functionality works very well, just like, importing data. The Python script is all drag and drop. So you can just drag the object into it, which is super helpful.
Definitely. Next is interpretation. This can be any name. I consider it my final interpretation, so I'll just leave it here. By default, it's interpretation 1, but I'll leave it set as this active interp. All right, so define model top, model base, target top, and target base. All right, so it's asking for my model top, and this is basically the full range that we want to account for when we're pushing data. So something to keep in mind is that if you drill outside of your model zone, you won't get any more data, right? So if you make it too narrow, if you define your model as just your target zone here, you won't get any uphole data pushes. You won't get any kind of information coming in as you land, right? So you want to give yourself enough room to land and also a little room below you so that if you make it the wrong turn, here at the bottom, you're still going to see data. If you do end up drilling out of your model zone, it'll just be blank, right? You'll still see surveys, but the log data will be blank. So something to watch out for.
Yeah.
So in this case, top 7, my top 7 horizon, I'm going to go with that one. I think that's a decent start point for my model. So I'll come here to my horizons and just start dragging and dropping. All right, my base, I think top 11 will work here.
And that's, he has the word top in there, but that's just because those horizons have been made from top. So for this generator, you want it to be the horizons, right? The 2-dimensional.
Right. Yeah. Make sure you're grabbing from the horizons here under your insert. Yeah. The top target base target. This is where your in zone percentage comes from, right? So this is your actual target zone you're trying to drill in, trying to drill the entire well in. In this case, top target, base target are already there for me. My type well name is already there for me. And here's where I want to define which models I would like to create, right? So I do have GR. There it is. Bulk density. And actually, I should be able to drag and drop these. So I'll just multi-select and drag them over here. And this is going to create 4 different model files for me, which we'll use later. Create image file of model. I can set this to true. It basically creates like a PNG image for me. It's got kind of an extreme vertical exaggeration. You could just open it later and check to see if it looks like something you'd expected. It looks a little bit like a very exaggerated version of this project as well, right? I'm gonna leave it at false to save time though. All right, I'm gonna run it. It's actually pretty quick. When we tested this the other day, it was like 5 seconds. Yeah.
Oh.
All right, so the models have been created. Here are some parameters. Here's where the models are saved. I can verify that I did it correctly just based on MD. That's about the expected length of my well, versus section TVD. And then the 4 different model files were created. These are NPZ files. So what they look like, here is my file folder here. All right, so I have 4 different files here ready to go. These are in NPZ format, and the StarSim script will require these later. All right, so that's it. We're basically just taking some curves off my type well, and we're creating model files.
Perfect.
Next, the answer model script. All right, this is an easy one. We just want to define the path to save this type of file. I'm actually going to save it in the same folder.
Yeah.
It doesn't really matter. I'll hit run. What this is basically our answer key, right? So I'm going to show you this again. It creates this pickle file. It's called simdata.pickle. And what happens in the end, once you simulate the entire well, if you're done running that StarSim script, you'll get a little text box that pops up, gives you your score. Also pop your answer interpretation open. So this is your answer key file. It pulls from this file and displays a second interpretation that you can compare with, right? So think of it like an answer key.
Think of it like a pickle. It's a pickle file. Never heard of a pickle file. It's sorry.
If you want to know what a pickle file is, check out that KB article. I put some information in there, but
Did you? Okay, go. I'm gonna have to check that out because I've never heard of a pickle file.
some kind of Python thing. I really would rather not try to describe it because I'll never do it justice. All right.
So
okay.
then mod, so you
At
did
this
model
point,
generator, answer model. Now it's W.
That's right. We've generated our model files. We've created our answer key. Everything looks nice. I think at this point, I'd recommend just saving this project. I saved it here as webinar model project. That way, if you ever want to come back and change your model in any way, you can make adjustments and then recreate your model files, right? So keep this separate, right? So if you ever need it, you have it, right? All right,
So Jeff,
Moz.
you don't need to have all the things displayed and all the anything displayed when you're doing this, because that's what this Python script is for, right? It's you're generating the model, so you're telling what horizons to use, what curves to use, what are the bounds, and it's going to reference this well, how this well steered based on those target names, horizon names, all that kind of stuff. Correct?
Right, like I have it all turned on here, but it doesn't have to be turned on. Yeah.
Cool.
So MAWS, we're on W, that's well cutting. So at this point, we're going to cut this well back somewhere under the top of our model. And that's going to be kind of our starting or reset point for the start of our landing and the simulation. So pop open Python again, go to well cutting.
So I will reiterate what you just said, Jeff. Make sure that you don't cut back outside of your model. You want it to cut back and still have a little bit of that well data in your model, right? Within or below that top model horizon that you chose.
Right. Yeah, I mean, it wouldn't be the end of the world. You just wouldn't get any data pushing until you cross that boundary, right? But I mean, you might as well start within the bounds of the model. So
start with where you have data.
Right.
It would be a pretty fun messed up joke to start it before when you're training somebody and be like, I don't know, there's no data. What would you do?
Yeah, that's right. All right, well cutting. You'll notice the first line says not processing wells. So this is in a scenario where you have multiple wells in a project. Here you would drag and drop the wells you do not want to cut back. So this is kind of a dangerous script to use in a project with multiple wells. If you forget to do this, you might end up cutting, right? You might think you're cutting the well you're interested in, and you're going to end up cutting every other well in your project, right? So use this script with caution. That's kind of why I recommend maybe just using one well at a time in your project. Since I have no other wells, I want to cut this one. I can just leave this value blank.
So wait, Jeff, you bring up a good question, or at least in my brain. Would you recommend making a copy of the well and then using a copy of the well to cut back and do all that kind of stuff to run this on?
No, because I mean, we already saved this project. Right, if you make a mistake, you can just close it, reopen it. Right.
Okay, cool.
Okay, so we're going to cut this one. We're going to find a good MD cutoff here, right around 13. If I look in the bottom left of my StarSim window, it's around 1360.
60.
I just want to make sure, yeah, 1370. So I'll double click, I'll just define this value cell. And I want to cut back every log, every horizontal log that I have here, right? So now I'll find them in the horizontal track. So GR, ROP, RT, and RHOB. I'm just going to drag them over here. Image logs. If you don't have an image log, you can just leave this blank. In this case, I do actually have an image log, so I'll just define it here. And then WGC comment. This is actually the name of the comment box that pops up at the end of the simulation. So we want to make sure to delete that when we're ready to cut back after we're done actually simulating. So I would recommend just leaving that as a default. All right, so once I hit run, it's going to cut everything back. Hit run. Okay.
Oh no.
Now it looks a little funny because my target line's out here, but I'll just bring that back. Right, I'm going to reset this DLS. Okay, so you see we have actual survey information here. I don't want my bit projection turned on. All right, so I've cut back to this point, just below my model. And if I zoom out, you can see that I'm going to start correlating from just below top of 7. All right. So again, at this point, I'd recommend saving a separate file. So we'll go to Save As. I'm going to name this one Webinar Sim Project.
Nice.
So the idea behind saving this particular file is that we'll set it up. We'll get it started. Actually, we'll probably do this again after we set up the StarSim script. We'll save it, and then the file will always be ready. The project will always be ready to send to anyone who wants to simulate this well, right? Yep. They don't have to do any additional setup. They'll just have the project, open it up, and start running it.
Perfect.
All righty. I'm going to flip back to a. All right, I'm going to jump into a solo project now. I want to show you guys what this looks like in solo. So essentially what I've done here, before I go through the actual StarSim script setup, I created a new global project in my admin panel. I called it StarSim and Starlight. So feel free to put this in solo, put it, call it StarSim or StarSim with a well name. Then everyone in your organization can just easily go in and access one of these wells. Right, you don't have to bother sending that local project around. Put it in solo, have it available for everyone. The only thing that will be required is the model folder. So those users need to be able to reference those model files. So
on a shared network or something, right?
Yeah, you could put it on a shared drive, right, and they could just point to it there.
I mean, that's actually a very good note, using solo to help streamline this and make it more efficient, and then having it as a standalone. So for those of you out there who, if you have solo, do this. If you don't have solo, reach out to one of your account executives. We can talk to you a little bit more about solo and kind of the uses of it. But that's a very good note, Jeff. I mean, that extremely efficient and effective.
Sure. Okay, last step, last script we're going to go through is the StarSim script. All right, so there's a bunch of rows here. So bear with me while we go through them. I'm going to do some clicking. I've actually sort of set this up already, but let's go through each one here. Passive simulator folder, we've already gone through that, so I'm pointed back to my model folder. Define the well names that should not be in the simulation, right? So we only have the one well still, so I can leave this blank. Define logs and log models. So it's looking for your lateral log name and then the associated model file. Okay, so if we look back at my folder, all right, so I have my GR with the associated GR NPZ file, right? RC, associated NPZ file. So I have 4 of those. Image log. So I have that image log. If you don't have an image log and you'd like to generate one based on the GR type log, you definitely can. Once you define this name and define that GR model, it will generate an image log for you, right? So if you want some practice with image logs, that's a good way to get some practice. All right, and actually what I've done, so it takes the gamma ray model, but what I've done here, I actually created a copy of the GR model, and that's, I don't think you necessarily have to do that, but just so I could keep everything straight in my head, I created a copy of that GR and I defined it here in the 4th row. Define step of extending trajectory. This is how much data I want to push each time I run the script. You can change this at any point in the simulation. You can push 500 feet at a time, 100 feet, 30 feet, right? Actually, in this case, we're dealing in meters, but I'm gonna push 30 meters at a time while I demonstrate this. All right, this is the part that you can't skip. If you try to skip this line, the script won't run for you. So if you have no ROP log, say you just want to do gamma ray, right? A lot of people are just interested in modeling gamma ray and steering off that. What we could do is do the same thing, right? I made a copy of this GR, just renamed it, and I can throw it in here, right? And it's going to create an ROP curve, but it'll actually be a gamma ray model. But you don't need to turn it on, right? It'll at least get you through this step. Here, I actually have an ROP model, and I already used it once up here. If I try to use it again, I'd get the error, so that's why I need to make a copy of the ROP in this case, right? So slightly different name, and I can define it here in the 6th row. ROP max target. This is if you're interested in calculating an ROP score, right? So you'd go back to your model project, you'd find basically your max ROP along the length of your lateral, basically your 100% ROP, right?
Yeah.
And in this case, it was like 22 meters an hour, pretty slow actually. So that's what I defined. All right. BS start. So this is the point where the in-zone percentage will actually start calculating. You want to be landed by this point. Here, I've defined it as 280. If you want to take a look at what that looks like, right? We're somewhere right in here. Actually, I think I have a polygon. Yeah, that's my 280 line. You can change this, right? If you want to give yourself a little more room for landing, right? Set it out a little farther. So that's what that row is.
Yeah, I guess that would be just however you guys internally define target entry, right? Yeah. If you want to say, hey, target entry is right when you cross the target, right? Or if you want to do it right at land point or whatever. So it'd be just, I guess, that vertical section number of where you want to start your lateral section, how you define your lateral section.
Yeah. And you feel free to change this each time you want to run it. Go ahead and set it up to your preference, right? Noise added to the log. If you set this at 0, it's going to be the most perfect log you've ever seen. Nice and smooth, very easy to interpret, very easy to look at. By default, it's 10. You can leave it at default. You can crank it up to 40. You're going to get a lot of noise in your log. It's just going to make things a lot harder, right? You can do the same thing for the image log as well.
That's actually pretty cool that you can do that.
Yeah. Yeah.
You can add noise in there, so it like actually makes it a real life scenario.
Make it really hard for your new hires. Yeah.
Yeah, yeah. So to say that, that's not like a percentage or anything, is it? I mean, like what is it, like 10? Because you said 10 and 40. 40 is like a lot of noise. 10 is, if for somebody who's just getting into this, to have a relative scale of what one is versus 100, or you know what I mean? Like, is 100 just like way too? Yeah, I can't even do 100. I don't know. You know what I mean? What is that? Do you know what that number is? Do you have an answer for that?
Well, it says Gauss distribution, so I feel like it will take the average value at a certain point and then assign it a bunch of noise within a range, right?
Perfect.
That's
Okay.
kind of how I interpret it, anyways. I don't really know the math behind
Gaussian
it, but
distribution.
yeah,
Okay, so it's a Gaussian distribution. Okay.
yeah. DLS of extend trajectory. So this is referring to your target line extension. It's asking for a landing DLS and a lateral DLS. So you can set this to what your max might be during your landing, which your drilling engineers recommend. You can put that
Yeah.
in. So
Yeah.
we're going to give ourselves 13 degrees max on landing, and we're going to allow for 4 in the lateral.
Get it.
All right. So at this point, I guess I should mention we should have a target line. If you don't have one, we'll just go right click on your well, go to new target line. It'll create one for you. Without this, if you try to run the script, it actually won't run without this. So if you forget, you'll be notified. So I'll go to target line format, make sure our extend trajectory is turned on, and we're just going to set it up at 13 for a landing, right? If I put it at 4, we just won't be able to get there, right? It just won't connect. So
So
13.
Jeff, at this point, do you click run on that Python script, or do we have to set up anything else?
A couple more little things to set up. We're close. We're close to being
Okay.
able to run. I just want to make sure the target line is all set up.
Okay.
All right. So we've kind of moved it down into our landing zone, somewhere in our expected landing zone.
Okay.
If you forget to define that DLS in the target line format, the way the extension works, it won't really connect it. We recommend just switching it to these values just for visualization's sake, just so you can kind of understand what's going on while you're pointing your target line out. So ROP multiplier, again, this is if you're interested in a score based on ROP. Basically, anytime you're sliding or when DLS is more than 1, you'll be penalized based on the ratio you set here. Define to which the point to which the simulation will go. We'll leave it at 0. Essentially, it'll go to the end of your well in your model project, or you can define the VS manually as well if you'd like. But I'll leave it at 0. It's the easiest thing. 15th row, it's ROP by default. You could actually delete this. It won't matter. It'll still run. So just leave it as is. All right, so I have StarSim pretty much all set up, ready to go. I have my well cutting script as well. I have my target line set. So at this point, again, if this is a local project, I would save it here. And then at that point, maybe I'd load it in solo, right?
The other thing, Jeff, to mention, maybe, I don't know if this is the right place, but you have the copy of StarSim there and the copy of well cutting up in your favorites. In the Python script, it would be good to, right click on that and set it as favorite, or drag it. What do you drag it to favorites, right?
Yeah, so during the sim process, what happens is I'll start running, right? But I can't really see what's going on over here, right? So to combat that, I'm just going to drag these into my favorites, and they'll pop up here in my toolbar. Do the same for well cutting, right? And now everything's set up. I can actually close my Python window, make sure I'm in geosteering mode, right? Make sure I'm all ready to go. All right. And now we're ready. We can start running the simulation. All right, so I'm just going to hit the StarSim script here, my favorites, and we're going to see more data pushed here in my well. I'm in solo, we're good to go. Okay, so you can see I got more trajectory, I got more log data. I actually had that Python window just snap up temporarily, but at least it allows me to kind of see what's going on, right? So now I'm just in geosteering mode. I'm correlating like normal, right?
See more data.
Set it up. I'm just going to push more data for myself. There's my logs. Let's keep pushing,
Nice.
right? Right. So as long as you set the target line out, this well path is going to follow this extension line, right?
Mm-hmm.
You're trying to predict based on bed dips where the best place to go will be.
Looking good, my dude.
Right. Let's do a few more. I want to show a couple things. All right, so image logs, right? If you don't have any practice with image logs, you can definitely create one based on your gamma ray model from here.
Mm-hmm.
The important thing to remember is that frowns are down, Keith, which means smiles are
Up.
up. That's right.
Yeah, baby.
So we're starting to, looks like we're starting to cut up sections slightly, so we'd expect to see a few smiles here.
Yeah, and the other thing to note, like StarSteer, if you don't have like with azimuthal gamma, you can write model on image log. You don't need to be actually taking an image log. So long as you have two channels up and down, as much as I think 64 channels, StarSteer can create an image log out of it. And then you can interpret, like Jeff is saying, your smiles and frowns.
Right.
So don't fret if you don't have an image log, but if you have ASCII gamma, you can use it up, down at a minimum.
Right. And it's going to be tough. I know what the model looks like, but I don't really feel like steering it. So
Yeah. Now, if you were if you were at a job interview or training, no, I don't feel like steering it.
Yeah,
I don't know
I'm
if
done.
that'd go over well, Jeff.
To speed up the process a little bit, right? Right, or if you want to change the amount of data you're pushing, I can increase this up to 100 meters. Close it out. Let's push some more data, and now I'm getting larger data pushes, right? And now the nice thing about image logs is that they're very good at predicting, or not predicting, but showing us where a fault might be. So I see a straight line here. I'm actually going to put a new segment right there. All right, so this tells me there's probably a fault somewhere in here.
Yep.
My dip's probably a little extreme, but all right, there's some good overlap.
Mm-hmm.
You get the idea.
I see them straight lines.
So that's kind of the process. We're going to run through that. Since it isn't solo, I'd like to just take a brief pause and let's take a look at this well in Starlight. All right, so here I am. I've been steering this well. I just landed. You can see my updated interpretation. We can actually see my target line here as well. I've set up some of these logs, both horizontal and vertical dimensions. And we have a new feature actually in Starlight.
I was about to say.
It's called GAS. So that's Geosteering as a Service. And I'm not too sure what this is going to look like based on my interp, but first thing we'll do, we'll just make sure we are in custom view, right? That way we can set up all of our logs and tracks. And you'll notice here in the settings, we now have an auto steer menu, right? So it's asking, right? You guys have seen this probably as a demo in StarSteer at least. We can run auto steer. It's that auto steering algorithm. It's the same thing we use in the World Cup to run the robot, right? So I'm going to try and base this auto steer correlation off gamma ray. in my well, and I'm going to choose the GR in the type log. Okay, you can see that it actually makes an auto steer interpretation here. So it's running right now. Oh, and it says, please select the start interpretation and start steer. So I forgot to do that. Right, so this is all based on the start interpretation. I'm going to come over here and make this one start.
If
Okay.
he's not on.
So there it goes. It's running now. Processing. All right, so this will always be running in the background. This is only in Starlight. You'll notice that in my StarSim project, I don't even have another interpretation, right? So this is Starlight users. It's intended to be there as a tool, just kind of a second opinion on the start interpretation. So, you know, I could toggle it off if I don't want to see it, toggle it on, right? We're actually, looks like we're quite a bit high. So we might want to adjust and maybe start heading back down into zone here. Right, I can actually double click this, make it active. And once I do that, you'll notice that my correlation actually looks not too bad, right? My well is definitely above my zone here, and that's where we're seeing a lot of the gamma overlap, right? I'll go back to my interpretation, double click it, hide this one. Based on my interpretation, I am in zone, right? But based on the second opinion, not so much, right? So
Yeah,
we
not
can,
so much.
not so much. So once I save this as default view, anyone that comes into default view will have the same setup. We can also tell it to always display the auto steer interpretation with this little slider here. So if you come into default view, it's always going to be on. It's going to be there as a second opinion. All right. So
Some of you may not want that if some of your viewers are the drilling engineers, because they'll be like, "Hey, what's going on here, guys? Why
yeah,
why are we following this one when that one says you go down?"
just keep it off.
Yeah, keep it up. We don't want to see that. But no, that's actually that this is actually a very nice piece, especially for those shops who do have Star Steer, Starlight, are doing a lot wearing a lot of different hats, right? Where you're in meetings, you're here, you're there, but operations is 24/7. This will help you out, right? And Starlight's on your phone, so you can take this bad boy anywhere. You know what I mean, and be able to visualize it, and it'll just be um, another set of eyes for you.
For sure. Okay, so I did a 500-meter data push here. Clearly, I did a horrible job, right? But as I mentioned before, we do get this pop-up box. I was 3.6% in zone because I pushed
Yeah.
half the well at once. So that's this WGC comment box that pops up. I also get my answer interpretation. So that was the answer key that we created based on the original model. And I can double click this. I can hide mine, right? And there's the answer that I started with. And you can see I got a little out of hand, straight up and out of the zone. So I can now cycle through my interpretation, right? I can check it out in the vertical track there, see what it looks like, compare it to my own,
And see where you went wrong.
and see where I went wrong, right?
Now, all said and done, you did this. Now, if you want to do it again to somebody else, how do you? It's
Yeah,
easy to is copy well cutting, right? You click that, and then it just
exactly. So, I mean, I've seen the answer myself, but if I want to practice again, learn from my mistakes, we'll just come up here, click the well cutting script, right? And I'm back to my original starting point. All I need to do is just adjust my target line again.
And it got
right?
rid of the answer. Nice.
Yeah, gets rid of my comment box and my answer, right? I just
Yeah,
have to
nice.
remember to reset target line, reset the landing DLS, and I'm ready to go again.
And that's even a good point to note for those folks that are working in solo one, two, that are might be training multiple people, right? You might want to, select this, reset it up for the next person coming in, right?
Mm-hmm,
So
mm-hmm.
so they don't see the answer.
Otherwise, they're going to come in and see the answer before they even start. So,
Yeah.
all right, so the changes have taken place in Starlight. But about a year and a half ago, we had a feature called Rewind come out. I just want to remind you all, if you're out there, if you're not using it, it's kind of a neat feature. You can actually click Rewind, and we can watch the well that I just drilled. I'm going to hit the play button. You can see I have my target line here. Surveys are pushing. All right, and this will save the entire history of the well. So even if you cut it back later, it'll be on a different day. You can kind of come back and review the changes that were made, the decisions that were made as this person was simulating this well.
Yeah, and what I like about this feature, I mean, it's great to know that it'll capture, all the information from this well, not just from what you last interpreted. So if you kept this well, you cut back, reinterpreted, cut back, reinterpreted, it'll save all of those, right? So long as you remember the day and the time that someone was doing it, you can go to it. But what's good is previously, before, without having Starlight Rewind, you kind of have to go back through your segments to kind of walk anybody through what your thought process was when you were steering, right? But it doesn't really fully get you there, because you might have seen, because you're going through segments, and you might have seen a marker right in the middle of one of your segments, right, that made you change interpretations or made you do something, make a move, where going through those segments doesn't really fully capture everything. Whereas with this, it captures the data, when the data is coming in, the decision that was made at the time of that data came, when that data came in. I mean, this is a very useful tool for look backs, and you can save it out as a PDF, right? And I think when you save it as a PDF, Chad, correct me if I'm wrong, but if you save it as a PDF, it's not just that one image; it's an image for all those timestamps, right? So it's almost
So
like flipping through a book.
wherever I'm on, I can just hit that little PDF button, save it, right, and it takes a screenshot with my zone stats, based on what I've set up in Starlight. Basically,
Okay.
something you're used to seeing in a Geosteering report, right?
So it'll take a screenshot at that moment when you hit PDF of where you are on that timeline. Okay.
Exactly. Cool. The other thing we can do, if we're in custom view especially, is we can generate real-time zone stats in Starlight. So you can do this on both your interpretation and the AS interpretation that we had before, when I was actively steering this. But right, we could turn on our target line. We could show our last surveys here, and this is the stuff that's pushed to that PDF report. So we'll set it up. We'll define our landing zone. Not super sure what it was, maybe 1700. Maybe not.
No, it was
1500.
Yeah, it was something like that.
Something like that. And when we exit, yeah. So I mean, we can look at our in zone percentage right here in Starlight as well for any interpretations that you have.
Yep.
So I think it's kind of a forgotten about feature a little bit, but it's pretty handy and pretty fun to use, especially on a real well that you just drilled. You want to look back and see the decisions that were made.
Yeah, not to mention if you've got the simulator running and it's running in the cloud, you can watch it on Starlight and see how well your person's doing in real time.
That's right. You can actually
see how well they are at decision making.
You can watch your new trainee or that person you're looking to hire. They don't even have to know.
Yeah. No, I think it's an awesome tool. I know a few of my clients have used it for training. do use it for training. So definitely look into doing it. And if you have any questions, I mean, like we said, you can rewatch this webinar, or you can find a step-by-step in the KB, right? Or you can always reach out to, your account executive, and they, should be able to help you out. So yeah.
Last but not least,
Oh,
if you're in Calgary, we're going to do a little lunch and learn session on the 27th here at the Rogii office at noon. I think we're sending out that info probably on LinkedIn. It is on Eventbrite already, I believe, so check that out if you're interested. If you want to bring one of your own welds, one of your own SS welds, we can go through this entire process together, right? And you get some free lunch out of it. So it's filling up fast already, so make sure you get in there, and hopefully we'll see you next week.
nice. Also, if you're in Houston, I don't want to jump over all over your
No.
your October 27th seminar, but we've got a happy hour coming out after work with Rogii. Brewston tour continues. We're doing it with our friends, our family members, BHL. We're doing it at Eighth Wonder, and it'll be early November. So that'll be posted all over our LinkedIn. So get ready for that. It's going to be a lot of fun. And for those of you who are going to be at the SPWLA golf tournament, we will see you there. It's going to be fun, guys.
Nice. It sounds fun.
Without further ado, I think that's it, right, Jeff? I think we.
Yeah, I mean, I don't really see many questions coming through. So, yeah, if you guys have any questions right now, definitely put them in there.
Yeah.
Just stick around for another minute or so.
Yeah, definitely. Jeff, good job, buddy.
Thanks for joining.
Yeah. Thank you, guys. Really appreciate y'all for joining, taking the time to listen to Jeff and myself. Yeah, I mean that Python script editor has got a lot of information, and same thing with that KB. Do not forget about that KB, y'all. Go in there; it can answer a lot of questions for you. And then we'll be posting this, Jeff. We
Probably
post these on the KB.
Yeah, hopefully it's up here by Monday.
So, if anyone, if you want to share this with any of your colleagues, we'll have it up. Watch it. Hopefully, you don't get tired of our faces. Appreciate you guys.
All right. Thanks for joining us, everyone.
Thank you. Signing off.